Okay, so we have people are designing a container that's an open-top, square-based rectangular box that will have a volume of 500 inches cubed. So what dimensions will minimize surface area? This is a lot like one we did in class, except in that one we were actually given, actually no, this is a lot like one we did in class because on one we were minimizing the area of a cylinder given the volume. It's just this is a different shape. So, well, actually we were minimizing cost of the cylinder, but it's very similar. Okay, so let's draw a diagram. It's got to have a square base. Something like this. Because that's a square, all the sides are the same. And some height, don't know what yet. And an open top, the volume is specified. So the volume we know is 500. Okay, it's a square base, so let's call that, I don't know, x, and then let's call that h for height. So we want to minimize the surface area. So surface area, you could call A or you could call S. Either one is pretty intuitive. I'll go with A. That's what we want to minimize. So the surface area is the area of all the sides added up. Now it's an open top, so we're not adding the volume or area of the top on. The area of the bottom right here is this base, x times x. That's the area of the base. Plus the area of the side is x times h. And actually the area of all four sides is the same. The area of this front side is x times h. This side is xh, that side is xh. So with four sides, all of area xh. So that's my area function. That's my objective function. Okay, it's got x's and h's, so we do have to use the constraint, which is that the volume is 500. So v is 500. Volume of a box is length times width times height, so x squared h. I'd probably solve that for h. That looks easier. So h would be 500 over x squared, and plug that in over there. That gives us area is x squared plus 4x 500 over x squared. Let's clean that up first to get x squared plus that x cancels with one of those x's in the denominator. 500 times 4 is 2,000. Write it as x to the minus 1. So there's my objective function in terms of one variable. I'm going to stop here, and then if anyone has any trouble getting past here or any questions about what I did, I'll answer those if you ask them, okay?